Hi there. In our last two videos, we had a look at the chain rule and then we had a look at the product rule. In this lesson, we're going to have a look at the quotient rule and how we can use the quotient rule to find gradients and tangents and stuff like that. So first, let's have a look at what the quotient rule is. Now, again, like in the last two lessons in your textbook, there are two separate ways that they have expressed the quotient rule. I'm going to express it in what I think is a slightly easier format. So if we have y equals u over v, so where u and v are both different functions, so we've got one function divided by another function, then dy dx, and again, this is exactly the same as what we see in these two boxes, okay? Dy dx is equal to v times u dash minus u times v dash divided by v squared, okay? So let's have a look at that in an example. So in this example, we've got to find the derivative of this equation or this function. Now, what we need to do is we need to work out what u is. So u, in this case, is sine of 2t, and v is t squared. So the next thing we need to do is we need to differentiate each u and v. So u dash is equal to 2 cos 2t, and v dash is equal to 2t. So now I take these things that I know. So I know what u is, I know what v is, I know what u dash is, I know what v dash is, and I'm going to put that into this equation or that formula there. So what that will look like is dy dx is equal to v times u dash, so that's t squared, times 2 cos 2t, minus u times v dash, so that's 2t times sine of 2t, divided by v squared. So t squared squared. Now we can just simplify that a little bit. It's not much we can do here, but we can call this 2t squared cos 2t minus 2t sine 2t divided by t to the power of 4. Okay, so now we can see that t is a common factor at the top. T is a common factor, and obviously it is a factor on the bottom. So what I'm going to do is I'm just going to pull that common factor out the front. So, whoops. So I'll have, therefore, equals, I nearly started writing the wrong thing, equals t times 2t cos 2t minus 2 sine 2t divided by still t to the power of 4. But what I'm going to do now is I'm going to cancel out t, and I'm going to make on the bottom t to the power of 3. So then I've got 2t cos 2t minus 2 sine 2t over t cubed. And that's my final answer. That's the derivative. So let's now have a look at another example. So in worked example 8 here, I'm just going to drag that over so it's not obstructed by what we did before. We need to find the derivative of this here, and hence find the gradient at the point where x equals 0. Okay, so when we're finding derivatives, when we're differentiating, we're finding, well, we call it the derivative. When we find the derivative, that is the gradient function. So that is something that we can use to find the gradient at any point on the original function, okay? So what we're going to do is we're going to differentiate this equation first, and then we're going to let x equals 0 in that derivative to work out what the gradient is when x equals 0 on the original function. Sounds really confusing. I'm sort of switching between original function and derivative but hopefully once we go through the example, it will make a little bit more sense. So again, we need to identify what u and v are. So u is equal to cos 3x. And v is equal to 2e to the power of x minus x. Okay, now we need to find what u dash and v dash are. So u dash is equal to negative 3 sine 3x. And v dash is equal to 2e to the power of x minus 1. So I know what u is, I know what v is, I know what u dash is, and I know what v dash is. So that's everything that I need to put into this formula to find the derivative. So I'm going to write that down. So we've got dy dx equals v times u dash minus u times v dash divided by v squared. Now, it's really important with the product rule. I was talking about how the order in which all of these things are put in didn't matter. In this case, it does matter because we're subtracting uv dash from vu dash. So make sure that you have got that the right way around, okay? So now I'm going to substitute the things that I know from up here into this equation down here. So, therefore, dy dx is equal to v times u dash. So I've got 2e to the power of x. I'm going to put some brackets around these. Minus x times u dash, which is negative 3 sine 3x. I'm going to need some more space. Brackets. Minus u times v dash. So that's cos 3x times v dash, which is 2e to the power of x minus 1. All divided by v squared, which is 2e to the power of x minus x squared. Okay, so I've got something that looks somewhat like an equation or a function. Now, what we need to do, so I found the derivative. There's not a whole lot I can do to simplify what we've got here. Okay, so let's just leave it like that. And then I'm going to let x equals 0 in that equation. Okay, so this is to find the gradient when x equals 0 because the derivative, this, is my gradient function. It tells me what the gradient is at any given point on the original curve. So we're going to let x equal 0, therefore dy dx, or we could call that the gradient, is equal to 2e to the power of 0 minus 0 times negative 3 sine of 0, close bracket, yep, and minus cos 3 times 0, so we'll just call that 0, times 2e to the power of 0 minus 1 in brackets, divided by 2e to the power of 0 minus 0 squared. Okay, so we've got quite a bit we need to work out here. So let's just keep evaluating. So therefore, 2e to the power of 0 is 2, okay, minus 0 obviously is still 2. Negative 3 times sine of 0. Now, if we have a quick think about our unit circle, so we're trying to work out what sine of 0 is. So if I've got a value of 0, and remembering that we've got our cos axis and our sine axis, so when x equals 0, when the value is 0, so sine of 0 is down here, that means that it's equal to 0. Okay, so on my unit circle, that value when we've got an angle of 0, sine is equal to 0. So negative 3 times 0 is just 0. So we've got 2 times 0, which obviously is going to equal 0. Minus, we've got cos of 0. So when the angle is 0, cos is equal to 1. So we've got 1 times 2e to the power of 0, which is 2, minus 1. in brackets, divided by 2e to the power of 0, which is 2e to the power of 0 is 2 minus 0 squared. Therefore, that equals 2 times 0 is 0, minus 1 times 1 is negative 1, over 2 minus 0 squared, which is 4. So the answer to that question of the gradient at the point of, or when x equals 0, is negative 1/4. Okay, so this is the derivative. That's the gradient function that we did up there. This is the value of the gradient at x equals 0. So we've kind of ticked off both parts of the question, and now we can move on to the next question. So hopefully those couple of examples have made things a little bit easier for you. If you're still having a bit of trouble, or if there's a question in particular that's giving you a bit of a hard time, please don't hesitate to email me at jason.doffe@education.vic.gov.au, or you can just reach me through Compass. Thanks for listening. I'll see you guys next time.